Today we're going to talk about one of the synchronization problems of the operating system, which is called the dining philosopher's problem. The dining philosopher's problem is one of the classic problems used to describe synchronization issues in a multi-threaded environment and illustrate techniques for solving them. There are 5 philosophers, from P1 to P5, sharing a circular table, and they eat and think alternatively. There is a bowl of rice for each of the philosophers and 5 chopsticks, from C1 to C5. Each philosopher has 3 states: thinking, hungry, eating. He has to be in one of them, and he changes his state alternatively. A philosopher needs both their right and left chopsticks to eat. A hungry philosopher may only eat if there are both chopsticks available. Otherwise, a philosopher puts down their chopstick and begins thinking again. The goal is to come up with a solution that helps philosophers achieve their goal of eating and thinking without facing a deadlock or getting starved to death. But what does a deadlock mean? A deadlock is a situation where the progress of a system is halted as each process is waiting to acquire a resource held by some other process. It happens when each of the philosophers has acquired his left fork, but can't acquire his right fork, because his neighbor has already acquired it. This situation is commonly known as the circular wait and is one of the conditions that result in a deadlock and prevent the progress of the system. Seeking to avoid a deadlock, this protocol has a philosopher pick up his right fork when it is available, but if her left fork is not available, put down her right fork. While this does avoid a deadlock, it can unfortunately lead to livelock. If all of the philosophers become hungry at the same time, they will all pick up their left forks, all put down their left forks, all pick up their left forks, all put down their left forks, forever. Since no philosopher gets to eat, a livelock also leads to starvation. Hence, to avoid a deadlock situation, we need to make sure that the circular wait condition is broken. We can achieve this by allowing the philosopher to pick up his chopsticks if and only if both of them are available at the same time.